Welcome back, gentlemen. Welcome to another video of What the Beep. Today, oh, what a mess. So, working on that one project, I have to roll Harbor Freight roller, bend a bar into a banana shape. Well, if you don't know Harbor Freight rollers, this is a die out of the roller. They use cheese head set screws to hold the driven die. This is the die that drives the material through the rollers to a shaft. And anybody that's worked with set screws and trying to drive a lot of power through a set screw, you know, doesn't jive. It doesn't. It gives it up. So, if you can see, I got this all goobered up already. I'm trying to cut a keyway in here. Then I'm going to do a keyway on the shaft and drive it with a keyway, like any shaft that drives anything under power, they use keyways. Harbor Freight, they like to mess with you. So, I started, let me get some measure sticks out here. This is like 3 inches. This is more than 3 inches. 3 1/4. It looks like deep, this hole where the shaft goes through. So as you can imagine, trying to run a sawzall down there, you see I got a cut in there. That took me like, I don't know how many hours. It was not a good time. To get the second and third cut, to get keyway, even a 3/16 keyway in there, was just going to be way too long and crappy. So, a tool that I have wanted for some time and I never got because they are expensive and you don't use them super often is a broach set. This set is for, well, you take this is called a bushing. Bushing, you stick it in a hole, you take the broach for whatever size keyway you want to cut, you stick it in the bushing, and you drive this down through here, all the way down through the hole, and it comes out the other side, and it makes a keyway cut exactly this size. This one is a 3/16. There's 1/4 inch, there's 3/8, 1/8 inch. There's a bunch of different sizes of these keyways or broaches that you can get. So the issue I ran into, you guys can't tell, look how long this bushing is. Look how deep that hole is. It's got a long way to go. You cannot run, where the hell is it, this broach off of, get in there, find the hole. You cannot run this broach off of the bushing while it is in material, because you would just snap this right off. This is high-speed steel. It's brittle, 1 step less brittle than carbide. So that will not do. So, and there again, because this is Harbor Freight, this is not a standard size. You see that flops around like a hot dog down the hallway. The next size does not fit in there. I would just bore this out to a next standard size and just use a new shaft, but that shaft runs through ball bearings in the roller, and then that runs through a slot, and it's just an incredible amount of work to go up to the next size shaft for this. So what I propose to do is cut a new bushing. I'm going to take this, this is Rando steel. It's stuff you find in a box, don't know what it is, but you scratch at it, you knock on it, you taste it, and it tastes like it'll work. So we're going to take this over to the lathe. This is a little bit bigger than the hole in this die right now. I'm going to turn this down to the size that'll fit in this hole and the die first. And I'm going to come up to this shoulder. That's going to be the shoulder that does the stop in that hole. After that, we're going to go to the mill, and I am going to mill a slot in here. I haven't exactly decided yet because 3/16 is a 3/16 slot. The next size bigger, 1/4 inch, you can see how much bigger this is, uses I believe this is a 3/8 inch slot. So I don't know if I want to do a 1/4 inch keyway in here or a 3/8 or 3/16, sorry. I think I am going to start with a 3/16. Make that, because I can always go bigger. I can always make the slot bigger, run this broach through and make the slot bigger, and the die, you can always go bigger. It is much harder to make the holes smaller and the slot smaller and everything else smaller. I don't have my metal shrinker yet. That's a whole nother expensive deal. So let's go to the lathe and start making a fool out of ourselves. By the way, this is the DuMont, right there, DuMont Minuteman Keyway hole broach set. Very, very nice hole broach, keyway broaching kit. I'll definitely use it in the future, I am sure, the way it is. But for now, we're just going to be using a broach and make our own bushing. And it is hotter than something out here. I don't know what, but it's super hot. All right, here we go. Over here on the Logan lathe. Wake up. Take a measurement of this bore. 8.800 inches. That looks really fast. Slow that down a gear. Rubbed off. Dial this in. I don't know if this is true increments or a half. Some lathes you dial this in 5 thousandths and you get a 10 thousandths cut. Other lathes, they have this set up where you dial this in 5 thousandths and you get a 5 thousandths cut. We're gonna find out. You would think I would remember, but nah. Crank up the speed here a little bit. Those chips are coming off blue. I wonder if this is like 4140 material or something. Off blue and they're hot. Let's see what that got us. We should be at 8301 right now. Yeah. Meh. 83. Should be at 801. We're at 803, 804. Gotta take off like 4 thousandths yet. Tight. should be pretty spot on. Yeah, 8, 9. Oh, man, my dyslexics today. 797. A little bit bigger out here. Must be some deflection. 80. Yeah, I'm gonna take a little bit more because it's guaranteed this isn't enough fit yet. Right now it's about a press fit. So yeah, it's like right there. I'm gonna take a few more thousandths and then I'm gonna go through with a file and clean that up and then it should be good. A couple of chunkies in there. I know they say you're supposed to file from this side, left-handed. I've just always done it this way. I pay close attention that I'm not smacking knuckles into the chuck usually. It's just what I'm used to. Round this edge off. See if that fits. Now there is a bunch of burrs in here from me pissing around inside of this die, so it's not gonna just slide right on until I clean that out, but I just want to see if it's close. And it's snug right there. Let's see what that got us. So we're at 793, 79, 2-ish, 790. All right, that'll work. That should be a nice fit on this side. Yeah, that'll be good once I deburr this die. Like I said, there's a bunch of burrs in there from me pissing with it, so. Okay, this is obviously too long for this die, or for this, yeah, this die, this roller die, but that's okay. I mean, it only sticks out here a little bit. We're gonna leave that. So let's go over to mill, stick this in a vise, and start working on a slut. We don't have to go far for the mill. We just go, whoop, pow. And we're looking at a mill. We're gonna try to use a keyway cutter to make basically the keyway slot. Let's see if this works out. It might be the wrong way, but we're gonna hang it a long way off the end here. Guaranteed this is all wrong. Don't do what I do. I don't know if that's too much overhang. It's pretty rigid, so I think it'll be okay. We are gonna find out the hard way. Power knee would be nice. We know that this shaft is basically 0.8. It is 0.793. And this cutter, well, before I stuck it in there, it was 0.188. So to find center, setting the cutter height to be centered in the shaft, take 2. Get your paper underneath here, wiggle it around until it grabs. We're gonna lock down our spindle just slightly right now. Get it off to the side here. And I already have my dial indicator set up here. And it's on 0. And the math. We know this shaft is 0.7920. So we're going to do that shaft. This cutter is 0.188. So we're doing the shaft plus the 0.188 of the cutter. And we get 0.98 is the total. Or see, 0.98. So you take that 0.98 and divide it by 2, And we got to come down with the spindly spinner thing, 0.49. Like I said, I already got my dial indicator set up here. I do have a Harbor Freight, the DRO caliper dealio, but the battery is dead like they typically are. So yeah, that's why I'm using a dial indicator. So we got to come down 0.49. 1, 2, 3, 4, and 9. Right there. Lock that spindle down. And that, get the magnet off. That cutter should be centered on that shaft now. If my maths are right. They're not always right. In fact, they're rarely right. Make sure we got clearance. So we gotta come all the way up to the vise here. Yeah, that should be good. Now, I have to go and measure one of those bushings to see how deep we're gonna go and make this bushing, because it's gotta match the other ones. Stay there. Don't go anywhere. Stay. 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 Should stay there. The depth that they have this slot cut in their bushings is 0.3865. So we're going for that. We're gonna write that number down just so we don't forget, make a mistake. Just so it's right here in front of our face. 3865 is the depth total we are going for. So I'm gonna turn the machine on. We're gonna run this cutter up till it just touches this material. I'm going to zero out my dial, and then we're gonna crank it in a little bit until we get till 3865. Right there, it rubs. Get it off the end here. Yeah, it looks like it's gonna be hard to cut, but whatever. All right, so put my dial at 0. Ridge should cut on the end here, so I'm gonna have to, I should probably cut that first to get that down even with this, but yeah, let's do that. Okay, I'm gonna try this at 20 thousandths. That was pretty good. I'm hoping the deflection isn't too bad here. We're going to find out here really quickly. So 20 thousandths. I just thought of as we're going to run out of depth of cut with this small little keyway cutter before we're at depth of what that what that broach should be at. we'll go as far as we can, and I'll have to flip this up and finish it off with an end mill. Let's see where we're at anyhow. There's the best way to do this. We are at 147. 147. We're not even halfway. So yeah, let me reset this up. I'm gonna put an end mill in here, turn this up, put it back in the vise and index it and all that stuff, and I'll bring you guys back when we're ready. Okay, we're all set up here again for the second time. I have my knee at 0. This is locked down. We're going to continue on with the end mill now. A pretty small end mill, so I'm going to be cranking this up pretty fast. And yeah, we have, what do we have? We've got like over 1/8 of an inch to go yet. So I'm going to be cranking through here, and I'll stop, take a measurement after a while, and see how much more we got to go. So I don't know how this is going to go. I never have much luck with these small end mills, but we'll see. I don't know. All right, 20 thousandths. Oh. Okay, I was interrupted. I think we were done with this cut, and I was about to try. Yeah, there we go. I think that's good. Let me back this up a little bit more. Let's see if this lays in here nicely. Yeah, a little snuggish. I wonder if I should leave that a little bit snugger or not. Maybe there's some junk in this brooch. I'm sure there's a little bit of crap in this, in the bottom of this bushing here too. Yeah, that goes all the way in. I think that's good. Yeah, it's getting looser. I think there's just junk down in there. Yeah, it sits nice and flush at these first couple of teeth, and that looks good. Let's pull this out and deburr everything. I'm gonna deburr these two edges, and I gotta cut this off. I can pick you guys up and show you. Cut it off on the end here. I went way past, just so I got enough room. We only need a small lip on the top end here. And throw it back in the lathe and clean up both ends. And we should be able to broach a hole, maybe, hopefully. We'll find out. Stick this in here. Just a little triangle file here. Don't need a real lot. Yeah, I don't think you guys can see, but I got it all kinds of goobered up inside of there from trying to drive something through there. So I'm gonna run. Does that one work? Yeah. This is well, it's flat on, it's a D-shaped file, flat on one side, got a curve. This is a fine something or other, I think. Smooth. We're just gonna run this through here. Try to clean up what I messed up, so we're able to get this new bushing in there. She's going in there, and she's gonna be just gonna line it up with that junk ass keyway that I got in there already. That's crooked, just like that. And then we're gonna send it. Just gonna send it, and then I'll pound it out after it's done. I don't think it matters too much that it sticks out the top here. And I think it's okay if it's snug in there. I think you actually want it snug. I'm pretty sure the instructions said that you want at least two teeth, or maybe it's 3 engagement. So as long as this goes in, yeah. 1, 2, 3, 4, and then it starts cutting. So yeah, I think that'll be okay. Maybe. We're gonna find out. So, all right, let's go. All right, it is day 2 now of this train wreck. I'm getting a late start this morning. It's not my fault. I started watching that guy, Vice Grip Garage, this morning on the tube, and well, you know how that goes. One video turns into 4, and 3 hours goes by, and the day is half done. So here we are. Let's get on with this. Going against all of DuMont's broaching recommendations and warnings. I was thinking about this last night, and I am a bit worried that when we're pushing this broach through, we are going to be engaged on almost every tooth on this broach at one point here. So there's going to be tremendous forces put down on this broach. And as you can see, it's not very big and fragile because it's made out of high-speed steel. So, I don't know. With that said, let's send it, see what happens. Okay, to give this broach its best fighting chance, I am going to be using my favorite lubricant for stuff like this, especially sliding parts that aren't sliding a lot. It's just a few times in, I don't know, just different situations. I don't know off the top of my head. ARP, it's assembly lube. It's made for fasteners, assembling engines typically. You get small little packets of this when you buy head bolts or head studs for high performance engines, or when you just need more clamping force. I've been through this before. Fasteners have different torque specs. And actually, if you order ARP studs, they'll tell you about the different torque specs in the instructions. Sometimes, most times, I think. Torquing a fastener dry is totally different. You get a totally different clamping force than if you had a lubricant on it, whether it's oil, the ARP moly lube, spit, water, what have you. Every little change in that fastener and what's under it, between it, makes a change in its clamping force. Even if you're putting 60 foot-pounds of torque on the torque wrench, you're still getting a different clamping force on that fastener, on that part, depending on what's on that nut or bolt surface, the threads in the washer, or the nut face bottom, the nut flange, the part that contacts the part or the washer or whatever. So anyhow, back to this. ARP, it's a moly lube, and I've tried different off-the-shelf moly lubricants, and they just, nothing compares to the ARP stuff. I don't know what they put in here or what they do differently, but this is the absolute best stuff I have ever ran across for being slickerly and staying where it's supposed to be, because with here, withstands pressures up to 500,000 pounds per square inch. It does not get squeezed out. Well, it does some, but it stays and it does what it's supposed to do. Like I said, I really like it for stuff like this. Oh, right here. Other uses: camshaft and cam bearings, lifters, push rods, rocker arms, valve guides, gears, bushings, press fittings. This is a perfect example of a place to use this. I'm going to use this on the back side of this broach, so it has a nice sliding surface in this bushing. This front side, once I get this back, this slot in here all lubed up with the ARP moly lube. This front side I am going to be using Tap Magic. This is Tap Magic, not number 2 whey oil, for cutting the metal. So yeah, that's what we're gonna do. This stuff is not cheap, and you see I am very low on it here. I'm gonna have to order a new tube. You can see it's just gray stuff. I'll try to get this down in here. I'm gonna have to like push it down in there, I'm assuming. Get it on all the sliding surfaces here. Oh, that slides nice. Alright, that's ready to go. Get that up at the top. Actually, I can pull that out right now. I'm going to get this lined up with where I had that existing mess up. This doesn't go all the way down, I think, because, like I said, this bore is banana shaped, so we're just going to leave it like that. That shouldn't affect it. I got it lined up where I started with the junk in there. I'll move it over a little bit. Right. Yeah. Yeah. Ah. I'll just push it all the way down. Yeah, we got it all the way down. That works. I'm really hoping this broach does not get stuck and I have to go back the other way. I don't think that's going to be good on teeth. But we'll find out. Let's get after it. You guys can see. Well, maybe. See where we can. Man, that's close. That one, not so much. That one, not so much. That one will have to work. All right, well, nothing left to do but make sure you guys can see. And we're gonna send it. Oh yeah, lube. Holy crap, don't forget the lube. Never go broaching any holes without lube. All right, now we're gonna send it. This would just okay. All right. Now I gotta find something to stick on there to push that the rest of the way through. There's metal in the teeth. It's cutting. I don't know. Find something. Maybe a punch would work. Yeah. Let's look at the punches. Oh, broken. Bent, broken. A punch. 3/16. Should slide right down in there, right? Safety glasses. Safety spectacles. How come there is never any safety glasses around? What is it with safety glasses disappearing? I swear every other time I'm at the store, I buy one of those 4-packs, 6-packs, big box full of them. And I'm lucky if I can find one all the time. There we go. Look at that. It's getting easier. Just gonna fall out the bottom. Oh my gosh. The punch even fell out. I feel like that should just come right out. Yeah. It's cutting nice, and those chips aren't totally packed in those gullets either, so there's a room for a little bit more. I could have went another, at least 1/4 inch or more of cutting material there. Oh, okay. Let's use this Allen wrench maybe to drive that last little bit. It's just about ready to fall out, so this should not take anything. There we go. And then what do we do? With my kit, I only got 2 shims. I don't know, and I think we got quite a bit to go here yet. So this one says the 3/16 shim. Put that one in. I swear when I was watching, what's his face? The guy that does Pledge Allegiance every time. Keith Fenner. I could have swore when I saw him broaching a Keyway once before, he had like 3 or 4 shims stacked in his. Give it a drip of cooling fluid yet. Now I know you want to do this in one motion if you can, but I can't. I'm just happy this is working as good as it's working the way it is. Line up. It just feels like it's gonna, yep, fell right out that time. I don't know if you guys can see those gullets. They're pretty full, but those chips aren't super packed. So that's good. No, I don't know. How are you supposed to measure? I guess you measure a keyway and then take half of that, right? We're gonna go 189. Wow. 0.189. So half of that, 0.093. That's how deep we gotta cut this. And I don't want to pull that slug out of there until it's cut all the way. So how do I measure this without pulling this bushing out? Oh, we got a long way to go, I can tell. So yeah, I like have not enough shims for whatever reason. Why is that? That shim, cutter. That felt tighter than normal. Why? I mean, there's fluid on there yet. It's going. Well, I think I know why. Because I'm getting past the material I cut out before already with the Sawzall. So it's getting more into a full cut here. Oh, still nice cuts, but not totally packed chips. They still have a little space in them. Now I know you guys at your shapers are laughing at me right now, saying stuff like, "It's taking you so long." 9.2. So we're at 1/8 of an inch depth. What did I say we gotta get? Oh, maybe we are at right depth. Or enough. Ain't right, is it? Yeah, that's right. Well, roll. Maybe I went too far. You guys watching and laughing at me? Why does that not fit? Well, that's weird. Fit when I checked? No, that way. Maybe. That does not seem deep enough. My measurement must be wrong. Where is it? Man, it's hard to tell. Yeah, that looks good. It's snug in there, but that's right. Because I want this keyway to stay in these dies, because that shaft has to go through those bearings. There's a bearing on this side of the die and a bearing on this side, and the shaft has to go all the way through. So the keyway can't be on the shaft. It has to be in this die and stay in this die, and then I slide that shaft along this keyway. So, however, I think what I'm going to do is I'm going to flip this around and run that broach through the opposite way, just to make sure things are doing what they're supposed to do. Okay. Just like we were, but using the same two shims, and I'm just pushing this broach through from the opposite end. With a little bit of magic. There we go. Took some material off. Oh, those are all dirty and shot now. That's fine. It'll be fine. There we go. Oh, definitely tighter going from the outside. Yeah, that looks good. I think we're good. Hopefully you guys can see keyway in there all the way through. I don't know if that's focusing. pretty clean all the way through. The only spot is where I was going with that Sawzall. There's a little, I went a little deep with it, but that's okay. That is okay. See if this Keyway stock fits in there without even cleaning it up. Yeah, it's a bit snug, but that's good. Like I said, I want this Keyway or key stock to, see, it goes in there. I'm gonna have to tap it in with a hammer, but I want it to stay in this die anyhow. Good. There we go. Key stock pushed all the way down in there. Cut it off flush at the other end, dug into the pulley a little bit, but that's okay. So there's a key stuck in there. It went in, I tapped it in with a hammer, but it slid in there nicely. It's a nice snug fit. I like it. So it worked, at least this time. So now I gotta go cut that keyway on that shaft and we'll be able to get to the actual job I was trying to get done. When I started this, I used that ARP Molly lube on the shaft as well. Man, it's a nice day outside. Here is that shaft that goes through that die, and I don't know if you can see these all marred up. They have these little basically flats cut in here where they had those set screws go in. There's two on this end and one on this end of that die, and that just, those set screws get sheared off on the side here, mars this all up, and then you got to pound it out, and it's just a headache. So I'm gonna pick a spot somewhere and cut that keyway through here. The bearing rides like right here somewhere. I'm gonna have to do some measuring. I don't think it's super crucial, but it's somewhere in here. So I'm gonna go with that keyway all the way up to the edge of where this outside, inside, outside bearing is and stop there. So probably gonna go with the keyway right through one of these existing junk holes is. I don't know which one. Probably this one, or this one, maybe this one. Back to the milling cutter, end mill. Just because it was set up and everything was dialed in. This is crude, but we're going to at least 4.5 here, ish. Maybe not. We'll go to right there. That looks good. Precisions. Just like yesterday, we'll start out with 20 thou. I don't think this shaft is hardened because of how I was able to get all goobered up and I was able to file it off. So, if not, we're gonna find out right now. Right now? Right now. Is it hard? It sounds different. It might be a little. It might be a little bit harder than that other shaft we were turning. Oh yeah, bad things are happening. That shaft must be something. Push the end mill up in some or something. That, I don't know. It must be harder. I don't know if I should do that keyway cutter, but then I've got a lot of overhang out here because it's hard for me to cut. Yeah, that sounds tough. Definitely a harder material than not hard. I am shocked that end mill did not just snap right off yet. I'm expecting it. It's coming. Does not like that one bit. But we'll keep going. I'm assuming if it is hardened, it's hardened all the way through. Oh man, like I said, I mean it gets gummed up or smeared from those set screws, and I'm able to file it off. I don't know. Maybe it's just typical Chinesium material. Random of whatever is thrown in the pot that day. Oh, my end mill left the chat. Oh, which I don't know. That's weird to me as well. Like it'll last that long, and then all of a sudden just nope, give it up. Just I quit. That's enough of that baloney. I have no carbide end mills whatsoever because, well, they don't give those away. Maybe you guys know where they're giving away carbide end mills. If you do, let me know. Take my whammer. Crank this down like a fruitcake. Let's destroy this one. $20,000s? Okay. Here we go. Spray some flammable WD on here, and then suck it up with the shop vac. Close we are, y'all. I think we're there. Yep. Just a little bit of, yeah, I think we're good. It's just the burrs on the outside of that are hanging it up. Okay, and I'm gonna get a file and clean up those burrs, make sure it goes on before I pull it out of there. After all kinds of grunting and fighting and filing, working with stuff, finally got this shaft to go all the way through. It is snug yet, but I'm gonna leave it like that because it might loosen up as I use it. So let's go throw it in the machine, see what happens. So this whole project, this is the deal. This die gets placed inside of here. And you see tolerances are just snug as all get out. And this shaft gets fed in through here, through that middle die. Wait, let's turn this around. I think this is the easier way. Yeah, and then through. And the shaft sticking out the other end, and there we go. So that is the driven die right there. And I adapted this so the Harbor Freight twirlier, the thingamajigger here, and go on there and there. And then we can drive this with power. Here is what prompted this project is this inch and whatever solid aluminum bar. Way over capacity for this, but I don't expect to collect warranty on this Harbor Freight dealio anymore. So anyhow, there we go. That is that finished project of that thing, twirlio thingy. Yeah, so I gotta roll that long bar. You can see I started on the end. This bar actually tapers. You'll see this in another project video coming up. It tapers and gets bigger and bigger and bigger all the way to like around here. And then it's, yeah, inch and a half. No, inch and three, yeah, inch and a half. So, yeah, that project finally done. At least for that die. I've got more to broach out later when I need them, but this will be good enough for now. Thank you all for watching this long ass video. I hope you enjoyed it. Yeah, please like and subscribe if you like the junk I do. If not, just ignore my video and go on to something cool. Have a good day.